Welcome to the session on modelling in mechanics, quantities and units. The objectives for this session are to become familiar with the SI units for quantities and derived quantities used conventionally in mechanics. The modern form of the metric system is the International System of Units, or SI units. These base SI units are used in mechanics. So mass has unit kilograms and the symbol of course is kg. Length or displacement has unit meters and the symbol is m. And time has unit seconds and the symbol is s. Let's take a look at an example. We are required to write the following in SI units: 7 kilometers, 0.0 grams and 0.5 minutes. Let's look at part A first. 7 kilometers equals, of course, 7 times 1 kilometer. We've highlighted 1 kilometer because we need to exchange that or change that into meters. And of course, 7 times 1 kilometer is equal to 7 times 1,000 meters. Which is of course equal to 7,000 meters. And now for part B. 0.04 grams is equal to 0.04 times 1 gram. One gram equals 1 out of 1,000 kilograms, which is equal to 40 kg. And now let's take a look at part C. We are required to convert 0.5 minutes to SI units. So 0.5 minutes is equal to 0.5 times 1 minute. And of course this is equal to 0.5 times 60 seconds. Which is equal to 30 seconds. Now let's have a go at example 2. We are required to write 2.4 times 10 cubed kilometers per hour in SI units. So let's solve this. First convert kilometers to meters. So 2.4 times 10 cubed kilometers per hour is equal to 2.4 times 10 cubed times 1 kilometer per hour. And of course we've specified 1 kilometer so that we can convert it to meters. And here we've done so. In particular, we've replaced 1 kilometer with 1,000 meters. So we have that this is equal to 2.4 times 10 to the power 6 meters per hour. However, it's not quite yet in SI units. We need to convert the hours to seconds. So here's the meters bit. So let's now proceed to convert the hours to seconds. So replacing h with 3,600 s, because 3,600 seconds equals 1 hour, we have that our expression is now 2.4 times 10 to the power 6 meters times 1 over 3,600 seconds. And so tidying up gives us that our expression is 666 and 2/3 meters per second. Now let's look at the units derived from the base units. Speed or velocity is measured in meters per second, ms to the -1. Acceleration is measured in meters per second squared, or ms to the -2. Weight or force is measured in newtons, or capital N, which is equal to kgm times s to the -2. And that is, of course, the long-winded way of saying it. Newtons is easier and conventional. Do note that kilograms do not measure weight. Kilograms measure mass. Also, weight is a force and measured in newtons. Force diagrams show some common forces. We will examine some of these briefly in this section. The weight or gravitational force of an object acts vertically downwards. So the force exerted by the object on the surface. The normal reaction force acts perpendicular to a surface when the object is in contact with the surface, as shown here, and denoted by capital R. The size of R is equal to the size of W, the weight. The force opposing motion between two rough surfaces is called friction. So suppose we have the direction of motion as shown in the diagram, then the frictional force is acting opposite that, as shown. Suppose an object is pulled along by a string. The force which acts on the object is called the tension in the string. If an object is pushed using a lightweight stick, the force which acts on the object is called the thrust or compression in the stick. There is an upward force exerted on a body which allows it to float or rise up when submerged in a liquid. This is known as buoyancy. Air resistance opposes motion, as shown here. Here the parachutist's weight is acting vertically downwards and air resistance acts vertically upwards. Let's now take a look at another example. The forces on a swimmer swimming through water are buoyancy acting upwards, weight acting downwards, forward thrust occurring to the right in this diagram, and water resistance or drag acting towards the left. This brings us to the end of this session. If you have understood its contents, you should be able to become familiar with the SI units for quantities and derived quantities used conventionally in mechanics. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.